Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at our P6. This particular P6 focuses on complex numbers and the ability to manipulate Cartesian and polar complex numbers using files. This video assumes a number of things that you've watched the earlier video on the setup. Have a copy of our P6 instructions, our P6 setup, and have some familiarity with things like function pointers, file IO, and passing and updating structures. So to begin with, what we want to do in this video is focus on the switches. And so I've created a little bit of a table here that will help us understand all of the possible combinations that we wish to handle in this project as it stands right now. Basically, what I did is I derived this from the P6 instructions, and you'll notice that in all cases, our arg v square bracket 0 is simply the name of the executable, and in this case, it's P6. Then what you notice is that our arg v square brackets 1, much like in our earlier projects, will then track the /h and the question mark. And also the tier 1 switches, as I like to call them, in other words, the ones that dictate the primary functionality of our executable, such as add, subtract, multiply, divide, conjugate, polar, Cartesian, and then /f and /g. Now, based on the number of arguments that are needed, then we can decide whether or not we can successfully run these functions. We're not going to check for the existence of the files or anything in the main. We're going to leave that to the functions themselves, but what we can do is we can check the argument count. And for instance, our /add, just like if you were to add two polar coordinates or two Cartesian coordinates together, you require two values. And so what we're going to do is we're going to get these pairs of values out of their respective files. So in other words, u.csv is going to be a 2-column CSV file where the first column represents X in the Cartesian world, X and Y, and V represents another set of values, X and Y. And what we're going to do is we're simply going to add the real and imaginary components together and get a new complex number, which we are then going to write to the file z.csv. Now, there's nothing magic about these file names. I just used U, V, and Z to make it a little easier to demonstrate and to explain that they can be any file names as long as they are valid CSV files, and in this case, 2-column CSV files. And so the same thing is true for the subtract, multiply, and divide. And all 4 of our primary functions here all require that we have an argument count of 5 total. And you can see the examples of how we would call these functions. And the only thing that's missing, if you've noticed, is that I don't have p6.exe listed under the example. That was just for the length of the table. Now, under the conjugate only requires a single value. And so in this case, we're going to read in a file, and then we're going to write out the conjugate to another file. Polar, likewise, just takes a single file in and then returns a single file out. Cartesian, same, basically allows for us to convert a Cartesian into takes the file that's assumed to be polar and converts it into Cartesian coordinates. /f and g right now as they stand accept a single Cartesian complex number. That can always change later on. This is just set up for this particular example as f of z is equal to, and then some function of z. And then of course we want to be able to handle the nonsense switch. So what we want to do now is we want to put these switches into our main. In other words, we want to handle triaging the switches. We're not going to go any farther in this video. All we're going to do is show that we can successfully handle the switches in our main, and we're going to keep a relatively flat structure in this particular case. And so what we'll do is we'll start off first with our argument count is less than 2. In other words, if somehow basically the user just doesn't put anything in, then what we want to do is we want to make an explicit call for help. So explicit call for help. And then what we can do now is under the else if branch, we can be confident knowing that we at least have 2 arguments, which means that we can look at our argument, our arg v square brackets 2, using excuse me, let me rephrase that. We can use our argv square brackets 1 using our string compare I, and we can compare it to /h to see if there is a match. And then not only if there is a match with /h, but also possibly a match with then /?. And in either scenario, then what we want to do is we want to make an explicit call for help, meaning that that is actually what the user intended to do. And I just realized I typed the wrong thing or said the wrong thing in the earlier example here. So in this case, when the user doesn't put in enough arguments, this is an implicit call for help, meaning that they didn't know what they were trying to do and they just ran your executable, hoping to get some feedback from it. And then while we're at it, we probably ought to go ahead and throw in the else, which should also trigger then another implicit call for help. Now, before we go any further, I want to emphasize that this is by far not the only way to triage these switches. This is just one way. And if anything, I err on a slightly more verbose style to help you understand how to go about doing this. As you get a little more sophisticated with this, I would expect for your triaging to look different than this. Now, what we want to do is we want to take a look at the possibilities associated with our /add. And notice that in order for us to successfully call /add, in addition for our argv square brackets 1 to have a /add in it, we also have to have an argument count of 5. And so if we do not have an argument count of 5, there's pretty much no reason to continue. So what we'll do is we'll lead off on these examples with the argument count. And so what I mean by that is it'll be the first thing that we check in each one of our compound switches. So we'll check to see if our argument count is equal to 5. And then once that's the case, then we'll reach in and check to see what our argv square brackets 1 looks like and whether or not it matches the /add switch. And in this case, if there is a match, then what we want to do is provide a printf. It simply says calling the /add functions. Okay, and I'm just going to leave this pretty vague for right now. We can come back and tweak this and improve this. But then hopefully you can see there's a little bit of a pattern here, particularly with the subtract, multiply, and divide. In other words, the only thing that really changes is not the argument count, but just simply the switch. And so a little bit of careful copying and pasting and a little bit of modification here. We have our multiply. And just take care to make sure not misspell anything. And then we have, lastly, our divide. And then now what we want to do is we want to take a look at the remaining switches, at least the ones that we explicitly handle. And if you notice here, all of these, the conjugate, polar, Cartesian, /f, and /g, all of them result in an argument count of 4. And so we can employ roughly the same technique here. Except what we'll do is we will first check to see else if our argc is equal to 4. And then for the second condition, we'll just jump right into the string compare I of argv square brackets 1. And what we'll do is we'll take a look to see whether or not that matches the conjugate switch. And let's make sure that we've got our matching parentheses, in which case then we're going to just have a print statement says calling the /conjugate functions. At this point then, since our argument count stays the same with the remaining functions, we'll just do a little bit of creative copying and pasting again. And for this option right here, this is going to be /polar, which is going to result in calling the polar functions, /Cartesian, which is going to result in calling the Cartesian functions, And then lastly, then the /f. And we actually need one more here. So let's go ahead and copy and paste this one more time for our /g option. At this point, we want to once again build it. And what we can do now is we can test to see if we have the correct behavior on the command line. So I'm going to go ahead and start command window. I'm going to cd to the directory here. This is going to be E233 projects, and then I'm going to look for my P6. And then go down my dist folder, debug min-gw, and there's our p6.exe. And what we'll do now is we'll just start off by putting in P6 with no switches, which you would expect to get the help. We do p6.exe/h, sure enough gets the help, /? gets the help. For that matter, any sort of nonsense should get the help. And then what we want to do is we want to take a look at just /add by itself, which is not enough arguments. And so we still get the help. But now let's go through and actually put in some file names that currently don't yet exist. Those are our two input files and then ultimately our output file. And remember, there's no validation on those. We just simply want to verify that it is triggering the correct channel in our if statements. And we do the same thing now for the subtract. And sure enough, we call the subtract function. We can do the multiply. And if we haven't mistyped anything, sure enough, we get the multiply functions. And then the divide, and sure enough, divide. And now what you want to do is go ahead and check things like, for instance, the conjugate. Now I'm going to go ahead and make an intentional error here. I'm going to provide too many arguments. And yes, sure enough, again, I get the help, which basically just tells me that I have too many arguments. We could probably be more specific on that. But if we provide the correct number of arguments for the conjugate function, we get the prompt that indicates that we're calling it. We can do the same thing with our polar. Polar seems to be wired up correctly. Our Cartesian, it also seems to be wired up correctly. And then we're almost there. Our /f seems to work. And then our /g seems to work. And so we have the structure of our program already set up. And so none of it really works yet, but we can triage our command line switches correctly. We have the return values for our functions, which we handled in our earlier video. And now what we can do is systematically go through and one by one make each one of our functions work. Now, just a suggestion for you, I would encourage you to go ahead and get started not only on those little singular functions of the add, subtract, and so on, but take a second to go ahead and prove to yourself that you can import one of the files. And for this example, I would encourage you to look back at some of the file demo videos in case you've forgotten how to use fopen and fscanf. I'll give you a little bit of a hint. There is going to be a comma in your format spec between the two values, and you will need two temporary values or two chunks variables. So there's going to be a chunks01 and a chunks02. So hopefully you found this video useful. As always, don't hesitate to reach out to me if you have any questions, comments, or concerns. And thank you for watching.